Okay,
Yes.
good morning, everyone. So we are happy to have Dr. Banani Roy with us today. Dr. Banani Roy is an assistant professor and director of the Interactive Software Engineering and Analytics Lab at the Department of Computer Science, University of Saskatchewan. She has been conducting research on human-centric software development, renovation, software analytics towards building human-centric tools and techniques for reliable, scalable, sustainable, and cost-effective software development, maintenance, and evolution. Recently, she received the prestigious Advising Excellence Award from the Graduate Students Association of the University of Saskatchewan. Last year, he received a similar award from the Computer Science Graduate Council. These two awards highlight her passion and sincerity toward her graduate students. She has worked or has been working with over 40 graduate and undergraduate students with high quality publications and research awards such as Best Paper Award and Best Poster Awards along with her students. Also winning Research Excellence Award, Gales Award, 75th Anniversary Scholarship, and so on. She is also involved in conference organization, most recently as Program Co-Chair for SCAN 2024 and General Chair of IWSC 2023. She received her PhD from Queen's University, Canada, in the area of interactive software engineering. So welcome, Dr. Banani Roy, and the floor is yours whenever you're ready. Thank you.
Yeah, thank you for the nice introduction. My today's talk is on leveraging large language model in software development lifecycle. Actually, we started these research projects recently after large language models come to the picture. So I'm going to talk about some of the research that we are able to publish and some of the research that are still in progress. So you already gave my uh, introduction, but still I put a slides about me. So I wanted to show some of my graduate students who are working with me. Some of them already graduated, like one PhD student graduated under my sole supervision. Then many master student, like 6 already graduated, and some are still working. And my research interests include software maintenance and evolution, software renovation, mining software repository, and engineering collaborative scientific workflow management systems. So here I put a slide to explain the motivation of this work. So saying goes, two are his human. So we are human being and we do mistakes. And developers who build software, they're also human. And when developers do mistakes, it causes software bugs, and these bugs could be catastrophic, as you can see from this slide. Catastrophic software errors or bugs doomed Boeing airplanes and caused a death of like over 300 people in 2018 and 19. And the bugs also nearly destroyed its NASA spaceship, like which actually costed a lot of money to the company. And the main reason identified is the lack of engineering culture, meaning that developers are not actually following software engineering principles. Also, like here, I put another picture about software bugs that caused cyber attacks and put a healthcare system on offline in Manitoba. Okay, so software bugs could be really severe, and also like due to developers' mistakes, software bugs happen, and developer mistakes also can contribute to the creation of legacy software. As you know, legacy software are the software that are useful, but those cannot be continued for development or for upgradation, and development like one of the reasons for legacy software actually happens due to the wrong design decisions. So recently we have migrated cold region hydrological modeling software, and which is for like a scientific computation. And we have noticed that this software was developed not following software engineering principles, and the developer took a wrong decision regarding the technology. And mm, like why I'm saying wrong decision, because it was developed using Borland C++, and over the time the Borland C++ actually got discontinued, and they had to oh, migrated like they migrated to a modern software systems, and we did the work, and we are successful regarding that. But this kind of uh, s- legacy software happens, or migration needs to be done due to like developers mistakes. So here I showed like we are successful in migration, and we are highlighted, but we learned some lessons from the migration, that why like software bugs happen, and why software needs to be migrated. And our understanding is that although there is a plethora of tools available for software engineering, like that developers use to build a software, but still developers lack support, and existing solution don't consider human aspects, like there is there is an understanding that developers are very smart. Whatever tools you give them, they will work around and they will build the software. But these things can create problem, as we can see from the bugs and the legacy software systems example. And also there is consequence. The consequence is that, as you can see from the slides, retaining software workforce, an emerging challenge for software industry and government. And the developer shortage is expected to reach 85.2 million by 2030. Um, so as the tools and techniques that are available for software engineering are not usable, developers are facing a lot of problems, and they're losing interest, and they're under a lot of cognitive load. And as the complexity of software is increasing, and the developers are actually losing interest in quality software development, that's why bugs are happening. Software is becoming like obsolete. So the question comes, how can we help developers with AI assisted tools, so that we can have less bugs and less migration issues, and there are different solutions available, AI driven solution available, that can help developers in different software development lifecycle, like design, implementation, testing, maintenance. We are also actually doing research on helping developers using AI based solution, but we worked on different machine learning based models, deep learning based models. But as large language models now emerging, and it is the hype, so we started using large language models. I'm sure everybody knows what is large language model and how it works. Still, I feel like I put a slides for the general audience, like what is large language models before I talk about how we are using large language models in our um, research. So here, large language models trained on vast amounts of data. That's the main thing, and it can give you like a human-like solutions. So there are a lot of models out there, including GPT. And key features of a large language model is that it has billions of parameters, and it is actually based on a transformer model which handle context over long text sequences. And large language models in software engineering can be used for requirement analysis, code generation and completion, bug detection, localization, software documentation, code refactoring, test case generations. And we are actually doing different research to make use of large language models. So we are trying to build like a prompt engineering technique. Then that technique could be used in requirement analysis phase, and we are evaluating large language model capabilities for different software engineering tasks like program comprehension, bug detection. And then we are also working on fine-tuning large language models for specific software engineering tasks. So I was talking about CREAM, which is a domain-specific software for hydrology. But in order to work in this kind of software, which contains a lot of domain-specific terms, like how we can help developers to understand this software better using LLM. So, and in order to do that, we need to do fine tuning, and we are using LLMs uh, and fine tuning LLMs so that developers can actually build this kind of domain specific tasks like software which is full of domain jargons. Then we are also working benchmark dataset creation, because when you want to fine tune LLMs, you need context, you need the dataset. So we are also working on dataset, for example, for bug detection, for clone detection, and different works have already published. So prompt engineering, so how we are working on prompt engineering. So different prompt engineering techniques that actually guide a software language model to generate output. And there are different techniques like zero shot, few shot, chain of thought. We already know, but we have actually worked on a new prompt engineering technique in this paper that I'm going to talk about now. So the title of the paper is Take Loads of Your Developers Automated User Story Generation Using Large Language Model. So in this paper, we actually applied large language model for requirement analysis, and it was published on ICSME in 2024. So the technique we developed like for prompt engineering is called refine and thought rat. So how it works, like in the context of requirement engineering, like what we did, that we have the requirement document which is called RAD, requirement analysis document. And from that requirement analysis document, we generated the user story. And this user story is has its format, and it is being heavily used in agile software development. So from requirement analysis document to user story, to like in that context, we have developed the rat prompt engineering technique. So in this technique, actually we have we have developed some prompting that refine the input, and then we applied the chain of thought techniques to get the output in a step by step manner that we usually do in chain of thoughts. So here in this figure you can see that we have the noisy context, means the requirement analysis document, which comes with lot of figures, a lot of noisy text, and we try to clean that document, get rid of all the graphical objects figure. Then get the filtered context, and we also worked on the LLM settings. So LLMs comes with temperature. So when temperature is greater than 0, it means that it gives you some undeterministic output. And from that settings we get the filter context, and from the filter context we did some voting that whether the filtered context or the refined requirement is better the original context or not. And then after this voting, if the LLM said okay it is better, then we actually take the precise context, and on that precise context we applied different prompting engineering to get the user's story from the requirement analysis document. So here you can see a sample of the requirement analysis document, and which talks about figure 1a and comes with lot of noise text. And we asked the LLM that uh, define this using a certain prompt, refine this document and give us um, a clean document which should not have a graphical object. So you see, and it also like remove the reference of figure 1 and all those things, and rewrite the text so that it makes sense. So what to the prompt was? The prompt was you're an assistant that help improve the input document. You will correct grammar mistakes, remove meaningless words or characters from the input document, and improve the formatting. So this was the text we used, and after refining, we used like three more prompting to get the actually user story from the analysis document. So in order to see the effectiveness of RAT, we created our data set, and the data set like consists of six documents that we have collected from a company, and we also collected some documents from like the software engineering books by Jan Sommerfeld. And then did manual evaluation using these four metrics, which altogether called RUST: readability, understandability, specificity, and technical aspects. And we actually went to Bell Mobility, and we collected, contacted with 76 developers, and then we asked their opinion about the generated user story. Um, and we also did automatic evaluation using BART score and align score. So they are very popular metrics for textual analysis, textual similarity detection. And like our result shows that in three research question. So the first research question is that can LLM generate improved user story specifications by applying refinement and thought prompting technique? So we actually see that correct requirement captured with RAT. So when when you do the requirement and give the requirement analysis document to uh, LLM, it needs to extract the functional requirement, and from the functional requirement we see that. So here, one example. um, the problem with this treatment is that the level of insulin required does not just depend on the blood glucose level, but also on the time of the last insulin injection. So the specification talks about it's a problem of the treatment, but when a rat is not applied, it actually captured the requirement, the functional requirement in this way, that the system shall collect information from a sensor to monitor blood sugar levels. The system shall calculate the required dose of the insulin based on the blood sugar level and time since the last insulin injection. But it is, the requirement is saying that it is a problem, so it should not consider the last insulin injection. So the functional requirement was captured incorrectly when rat was not applied. But when rat was applied, we noticed that it actually didn't consider the uh, last insulin injection time. It just considered the blood sugar level. So that is an example of the effectiveness of rat. And you see here research question 2: how accurately can we generate user stories from requirements documents? So BART score and align score are promising. Um, and from our 76 developers user story, with the Rust metric, readability, understandability, specificity metrics, like specificity and technical aspects, which comes with a lot of questions. And as you can see, that readability was really good, but it actually struggles with a little bit like a technical aspects, but the result showed that like developers actually like the generated user story. And we have also developed a tool called Genius Generate User Story. And when you give the requirement analysis document RAD here, it can give a formatted user story that user like developers can easily use in their uh, agile development settings. There are, of course, some threats in our study, that requirement documents from textbook might not be the same as real life applications. And like our study, like our data set was not that comprehensive, and BART score and align score results like didn't match that much, but we are working on it. So in future, we are planning to use a large scale um, uh, experiment using more user stories, and to see the effectiveness of the work. Okay, so here I put a summary that what I just talk about. So we used LLMs in requirement engineering phase to help developers like create user stories from the requirement analysis document, which actually takes a lot of place when it is done manually, and which is kind of error prone. So our at work actually helps developers in requirement engineering phase. Okay, so now I'm gonna talk about how we are evaluating LLM's capabilities in a different context. So here is one of the work. It is called autogenics. So this work has published in Scam 2024, so very recent work. So autogenics, it's like automated generation of context-aware inline comments for code snippets on programming uh, question and answer sites using LLM. All we know that source code comments are crucial for enhancing code comprehension. Code snippets in programming question and sites like Stack Overflow often lack of comments. So if you notice, if you use Stack Overflow, I'm sure you guys use it, but those code snippets don't come with comments, and several factors contribute to the absence of comments. Uh, One reason is that Stack Overflow participation is voluntary. Developers face time constraints. Manually adding comments is tedious. Snippets on Stack Overflow are typically brief statements and not full methods. So that's why comments are missing in Stack Overflow snippets. And But like as it's not a full method, that's why like we thought that inline comments fit better in a Stack Overflow context. And a lot of research is going on automated comment generation tools. So we thought that why not we see the effectiveness of inline comments in Stack Overflow code snippet. Just to refresh your memory, what is inline comment? So inline comment is a single line comment typically used to explain or clarify a specific line of code. And in Python, it starts with hash, and starts in Java, it starts with two forward slashes. So here you can see how the method level comment look like, but here you can see how the inline comment look like. So it just comes beside the statement of a program snippet. So what is the motivation behind this research? Why do we want to see the effectiveness of inline comments in Stack Overflow? Because as you can read from the slides, more than 582K answer code snippets have neither inline comments or nor explanation. And when code there is no code, it actually cause developers frustration. Here one comment added like why don't you explain code a bit. So sometimes actually developers demand explanation for a posted solution, and if developers don't post comment comment, what happens, the score of the posted solution becomes zero, and it also hampers the reputation of the developers. So, lot of research exists, I was saying, to generate comments, but no research exists to see the effectiveness of inline comments in Stack Overflow code snippet using LLM. So, what we tried to do, three research questions, that how effective are LLMs at generating inline comments for code snippets found in Stack Overflow answers, and then in research question 2, that how do developers actually like the generated um, inline comments by the LLM, and research question 3 was can we introduce a tool into a Stack Overflow to generate context-aware, noise-free inline comments for code snippets, and are these comments more effective than those from standard LLM? So our contributions are in threefold. So manual evaluation of the effectiveness of LLM generated inline comments, then a survey of developers' perceptions on the inline comments, and then development of autogenics browser plugins that actually consider the context and um, apply some rules to get rid of the noise comments from the code snippet and make the inline comments more usable for the developers. So in our research methodology, what we did, here we have like 5 steps in our methodology. So data set preparation. So in the data set preparation, what we did, like we considered the code snippets, 200 code snippets from Python and from Java. Like we did random sampling, and we have actually take code snippets from a small to large. Like we divided the code snippets based on its size, in 4 quadrille, like small, medium, medium, large, and large. So then we applied like a Gemini 1.4 to generate inline comments. So we did prompting. So this is the code snippet. We asked the large language model, can you generate inline comments for this code snippet? Then we evaluated the effectiveness of the inline comments. But then we actually figure out that the generated inline comments have some knowledge. Then we applied our technique, how we did it, that to clean some inline comments which are not necessary. So we actually created a Flask-based application, and from the client side, we give the like the question text and the answer. And in the server side, what happens, from the question, like from the question answer pair, the question is separated and ask the LLM that can you create the code context for this question text? Then LLM created the code context, and then the code context is used to generate the inline comments. And from that generated code snippets with inline comments, we applied some rules, like to figure out the unnecessary comments. For example, remove comments from the library, or remove comments from the print statement. So we tried to apply some refinement technique, and then we finally got the refined output, like code snippet with inline comments. So with our result, like a research question one, we actually figured out that sorry, here Gemini 1 Pro model highly accurate and adequate inline comments, especially for moderately longer code snippets. And GPT-4 excels with comparatively shorter snippets, as the Gemini 1 Pro is cost effective and performs comparably with the GPT-4. So here we showed that even we use a small size large language model, and this kind of model actually works better in this context. And here our survey results. So then we take the generated like 16 code snippets, like 8 from the Python and 8 from Java, to the developers, and we ask them to determine the accuracy, adequacy, conciseness, and usefulness of the comments. Um, so they told them they are useful, but some of the cases they told that this direct use of LLMs actually show some uh, noise. And but when like without noise, and we compared then without context and with context, like the autogenics architecture that I was explained. And as you can see the comparison, that without context and with context, like the accuracy actually increases. Then like comparatively, that with context, things are better. So here I give a concrete example, like how with context, like the autogenics architecture works better. So comment generated by standard LLM without context. So you can see that for some of the cases, it generates comments that are actually not necessary, like for loop, iterate over indices from 0 to n minus 1. So these kind of comments are noise comments which are not necessary. But for autogenics, we don't have this kind of comment. For example, it generates like we without context, it generates comments for print, but for like with context, with our autogenics, it didn't create any um, uh, comment for this print thing. And most important thing is the context, like how it is applying context. So for example, why train, um, it's a variable. So when it talk about y train, so it number of elements in y train 1, it didn't talk that y train is a training set. But the autogenics were able to provide the appropriate context and make the uh, like code snippet more usable, readable for the developers. So in summary, LLMs improve in accuracy and usefulness with increased code length, but struggle with conciseness when the like code length increases. The survey shows the demand for automated tools, and autogenics can assist developers in code comprehension task. And we want to actually, we did our research in Python and Java only, but we want to expand the research for more languages. How much time I have? Okay, 43.
You have about 10 minutes.
10 minutes. Okay, so I should be able to wrap up in 10 minutes. Okay, so I talked about prompt engineering, evaluating LLM's capabilities in our research, but I just gave some of the example work. We are doing more things, but due to interest of time, I'm not talking about all the research. So another like uh, like before I go to fine-tuning large language model specific software engineering tasks, so one of the work we have also done on large language models, it's are large language models a threat to programming platforms, and exploratory study. So in this study, we tried to see the capabilities of large language model for problem solving cases. For example, there are different online platform like HackerRanks. Though using those platforms, developers try to build their skill, and where you can find lot of problem solving programs. And we wanted to see like how LLMs does in this kind of problem solving platforms. So I would request you guys to read this paper. It's an interesting work, but I'm not gonna discuss this work now. But I will move to like the fine tuning part, like how we are working on fine tuning large language models to do a specific task. So one of the master student is working on it. It's like leveraging LLMs to provide domain specific knowledge support to domain naive developers. So uh, I mentioned about CREAM earlier, cold region hydrological model, which is a scientific software, and it can actually uh, model the behavior of a hydrological system. And using this kind of system, what you can do, like you can predict whether flood will happen or not, how much runoff will happen when snow melts. So this kind of prediction can be done using this scientific software, and it uses a lot of mathematical models. And we migrated this software, but when we are migrating this software, we faced a lot of problems, because this kind of software actually built by a domain expert, and the domain expert might not know all the software engineering principles. And when they built these software without software engineering principle, maintenance can become a very difficult thing. So the thing what happened in migration, we realized that the scientist developers who actually build this kind of software have domain knowledge but lack software development expertise. But software developers, those who are expert in software and engineering principle like us, we have the software development experience, but we lack domain knowledge. So how we can actually how we can transfer knowledge between the scientist developers and the software developers. So and how we can actually facilitate the cross domain collaboration. So when you are doing cross domain collaboration, you actually face different terminology, and you feel and when you don't know the terminology properly, the simple things become complex. So what we did for this kind of knowledge transfer, while we are trying to comprehend the code base of cream, which comes with lot of domain specific terms. So we thought that okay, if a developer looks at a code snippet and face difficulty in understanding the code snippet, what could be done? He could pin code snippets that they don't understand, then ask question in natural language, what this terminology mean, or what's the purpose of, like, SWE is a variable there, like we don't know what is SWE. So if that variable is select and ask like what does it do, then the ID where LLM is embedded, it can tell that it is no water equivalent variable affect. So it can give the appropriate clarification of that variable. So with that solution, how we worked, like we collected the we did fine tuning, and we collected the documentation files that we converted in a vector form, and then we check the question text, and from the the question text is again converted into vector form, and then question this question vector is compared against documentation vectors on cosine similarity, and we took the answer that matches most with the question. Uh, so we are still working on the plugin, and we are also working on creating the appropriate documentation for Trim that actually will be used to fine tune the large language model and to get the appropriate results for the natural language based query from the developers. And it is, the survey is still pending. I might ask you also guys to do the survey, like how the plugin is working, but it's a very promising work that we are doing, and we feel like if we could build the plugin for the developers for this kind of domain specific software, it would be really helpful. Yeah, there are always threats. So we need end user documentation, we need architectural documentation, and retrieval of documentation needs to be verified, like correct document. That's very important to do the fine tuning. And we are not like we just started, but we are not done with the end users yet. Okay. So the last point is benchmark dataset creation. We are working heavily on it. So one of the master student is working on real-time bug localization in Java code, leveraging source code and LLMs. So here we are also developing a plugin for ID, where we are building uh, like we are developing a benchmark data set for particular type of bugs. Like there are many benchmark available, but we have noticed that for a particular type of bugs, not that many samples are available. For example, null pointer detection, or memory bugs, or security bugs. So we are trying to create data set from using LLMs for this type of bugs, and we are integrating the model in the ID, and then we are actually trying to detect bugs in real time. For example, when you write code in ID and you try to commit it to the um, um, repository like GitHub, then this kind of plugin can tell, like, okay, your program has some bugs because maybe some of the variables are not initialized, or somehow there is a possibility of null pointer error. So like with this research, we are trying to make like a bug detection more usable for the users. Sorry, due to the lack of time, I'm not going in details, but if you are interested, we can like share you the paper. We just submitted the paper in SME this year. So the future of I'm done talking about the work, and here I have some future work that we can consider using LLMs. So we need more fine-tuned models for a specific task that we can see, because when uh, LLMs are not fine-tuned, it can hallucinate, and it can give wrong results. And we have seen that it hallucinates more for the long text. So fine-tuning helps a lot here, and need to work more on the determining the capabilities of LLMs. So we are using LLMs, but we really need to make sure its performance on different software engineering tasks, because uh, we are using software in different sectors, and for critical domains, like it's really important to ensure the correctness of code snippets, and assisting software developers in more usable way. So we need to build more plugins in the ID, for test case generations or for bug detections. So if those things can be done, it will be helpful for the developers. Then developers will are gonna make less mistakes, and we don't need to migrate software system that much, and it's gonna help developers taking like good decisions. So here is the conclusion. Like in our research, we are leveraging large language model for different software engineering tasks, which include program comprehension. Like we are generating inline comments for program comprehension. Like we are doing clone detection using a large language model, and we are also working on software documentation, like generating release notes automatically. So one of my PhD students, Srishti, just finished his PhD on documentation, but she also used a little bit of LLM in her work. But we are exploring how we can use LLMs like for architectural documentation. Yeah, here are some references. So yeah, so if you have any question, please feel free to ask. I'm done. Thank you.
Okay, so thank you for your nice talk. Any questions? Questions? So I'll have one question. So it's very interesting that you presented that how the native developer can be benefited from LLM, right? Is there a specific model you trained for that purpose? Like what kind of large language model you are using for that purpose?
Yeah, so we are using like ChatGPT, like a GPT model. Yeah.
Okay. And the research is considering also like how much, like how do you define the native developers? Is there any definition that can be used or help us to determine the degree of the nakedness of the developer?
Sorry, can you please repeat? I could not hear you properly.
Oh, okay. So I'm just asking that how do you define these native developers? Like they don't never committed to the repository or they have like limited
Oh,
experience?
we are like a naive developers means like who don't have that much knowledge about the software. So we are hiring, for example, students who never worked on Cream. So those
Okay.
developers don't have any knowledge about the software, like what are the um, what are the domain concepts that are used in Cream. Okay, so
Okay.
so
Thank
we are
you.
calling domain naive developer. Those
Okay.
who don't have the knowledge about the domain, but they know software engineering, they know programming, but they just don't know the domain. Okay.
Domain. Okay. I think we have one question. Aaron, do you have any question now?
Yes.
Yeah,
Hi,
please go.
Dr. Roy.
Hi.
Can you hear me?
Yes, I can hear you. Go ahead.
So you were talking about hallucinations in your large language model. Are you trying to do something to mitigate those hallucinations? And what percentage of them are you really seeing? You said that you're seeing it in large text, if I'm right.
Yeah. So when I was talking about the RAT prompting technique, refine and thought, so we used requirement analysis documentation, and those documentation are very large. So we try to see like how large language model does without RAT, like just simple prompting technique, chain of thoughts. And we have seen that the generated user story from the RAT was not that much usable or readable. Like the core matrix, we have used Rust, but when we used the RAT technique, like and in some specific prompts, like it gave more accurate results, so it hallucinated less. Yeah.
Understood. Thanks.
Yeah.
Okay, let's thank Dr. Roy again, and thank you for joining with us today.